Hi all. So in today's video, we will be discussing the second part of organic chemistry. Like what we discussed in the last class, just the continuation of the same. I'm just recollecting what we discussed in the previous class. It was all about a nucleophile and an electrophile. A bond is forming when an electron is donated by a nucleophile to an electrophilic center. That is a key aspect of any like bond formation, or it is a key aspect of any mechanism. This electron moving. So when we are saying about that electron donation from a nucleophile to electrophile, I can see that is a new bond formation. And if it is a CC bond, C single bond C, it's a very important reaction in organic chemistry. In today's class, what we are going to discuss is how this organometallic reagent is helping to form a CC bond from a C double bond O group, from the carbonyl group. Here also, today also, we are not going to study something new. In the last class, in the previous class, I told you, if we are able to find out the nucleophile and electrophile, then it is over. That particular reaction we can write. So when we hear about organometallic reagents, this is something big. We don't know what is the mechanism. There also, just find out the nucleophile and electrophilic center. We can write the product because I already told carbonyl group C double bond O, that carbonyl carbon is electropositive or it is an electrophilic. So that is the particular electrophilic center, particular reaction. And if I am considering organometallic reagent, let us say lithium C, lithium carbon bond. The last class I told you, if an electropositive metal is associated with a carbon, they can donate that sigma bond or it will act as a nucleophile. So if we are able to find out the nucleophile and electrophile, we are able to find out the product, whether it is an organolithium or Grignard reagent or whatever it is. Okay, so without much delay, we can discuss that. Let us discuss. So here what we are going to discuss is, okay. Here using organometallic reagents to make CC bonds. Just recollect what we told last class. Here there is a carbonyl group. This is the positive, like electrophilic center. The last class we told that here there will be polarity here. And this carbon in here, this carbon is there will be polarity. Here electron density will be higher and this center can attack here. That's how a new bond is forming. So once it is formed, it will be protonated. The same mechanism you can follow here. Here also, just consider the bond. Here, it will add to this, you will get the product. Likewise, you can try what will be the product here and here. So this is what this organometallic reagent is what, and how this reaction is happening. This you already learned in the last class. Okay. Now, coming to this This is a table in which electronegativity of selected elements. Here we could see that fluorine has the electronegativity of 4, oxygen has 3.5, like that. Now, when we consider a particular carbon metal bond, let us say CLi sigma bond. This CLi bond is polarized towards carbon. This sigma bond is polarized towards carbon. Because if there is a more electronegative atom, comparing to carbon and lithium, carbon is more electronegative and the electron density will be more here, right? That's what. So this bond is polarized and MELI attacks electrophiles here. Here, this center will attack this center because here also we are told this carbon is, when we compare the electronegativity of carbon and oxygen, this is more electronegative and CO pi bond will be polarized towards oxygen. And here there will be positive, here there will be negative. So this particular center will attack this center. So here when we say there is a new CC bond is forming, there is nothing, just a nucleophilic center is attacking an electrophilic center. So the key point is that we should understand this is the nucleophilic center and this is the electrophilic center. That's only we should know. Now, consider the orbital diagram. Just consider the orbital diagram of LiC, lithium carbon bond. Here we can see that the field, here it is lithium. This is the lithium atom. This is the carbon atom. So we know that here more electronegative is this. The more electronegative atom will be the energy or atomic orbital. So here when we see the field at CLi sigma orbital, it is closer in energy to the carbon's sp3 orbital than lithium's 2s orbital. Then we can say that carbon's sp3 orbital makes a greater contribution to the CLi sigma bond, and that CLi bond has larger coefficient of carbon. Okay, just think that. That's all about their orbital diagram. So when there is an electropositive atom associated with carbon, we should say this is the particular nucleophilic center and this will attack an electrophile, and this is basically from the difference in the electronegativity. This is evolving from the difference in electronegativity. Okay, now coming to like how to make organometallic reagents, how to make Grignard reagents. When we hear Grignard reagent, it is something big. We will be scared by hearing Grignard reagent. This is nothing but just RNGs. So how we can make this particular Grignard reagent? Here, Grignard reagents are made by reacting magnesium turning circle with alkyl halides in the either solvent, then THF, such solvent. Here also we could see. Here also we could see. Here there is an alkyl halide, MgTHF. We will get the product. Here also. Such a way we can say that this is how they are making our Grignard reagent. Just see the solvent, just see the Mg. So diethyl ether and THF are the most commonly used solvents, but you may also meet others such as dimethoxy, ethane, and diethyl. Okay. Now, here, what is the mechanism actually? What is the mechanism happening? when we are making an organometallic reagent, or when we are making an organometallic reagent. Here, it's just an insertion. This is our carbon halogen bond. This is our carbon halogen bond. So it's just an insertion of magnesium into the carbon halogen. And also here there's a change in the oxidation state of the magnesium. Magnesium earlier it was in magnesium 0 and after it will change to Mg2. So that we can tell that it is an oxidative insertion reaction. This is an oxidative insertion or oxidative addition. Okay. Now this is how we are making Grignard reagent. The same way we can form organolithium compounds, organolithium reagents. Just take an alkyl halide, react it with lithium and lithium metal and a solvent. Either it is a pentane or Et2 or THF, whatever it is, we'll get the product. We'll get that particular organolithium or Grignard reagent that we are interested. This is also important. Now we want to discuss organometallics as a base. So this organometallics should be kept absolutely free of moisture. Should be absolutely free of moisture. Even if in air itself, if some moisture is present, it will destroy that. Because they are very rapidly and highly exothermically react with water and they will form alkanes. They will form alkanes. Okay, so anything that can protonate, anything that can protonate them, it will form will particularly form that particular alkene. Okay, it's like we can see here this equilibrium, like towards right. Like this particular thing. Towards right. That's what the reason. Now here, making organometallics by deprotonating alkynes. Consider alkene. Consider alkynes are sufficiently acidic. They are sufficiently acidic. And these things can be we can make organometallics by deprotonating alkynes also. Here you see what happened. We made this this particular organolithium, and this center is added to this particular electrophilic center. You can see what happened in this mechanism. Okay. So when we consider alkynes, they are most acidic of hydrocarbons. They are most acidic of hydrocarbons, and they can be deprotonated by more basic organometallics such as butyl lithium or ethyl magnesium bromide. They can be deprotonated. So here when we consider this is an alkyne center. This particular Grignard reagent can deprotonate and they will form an organometallics. They will react with particular electrophilic center and form the product. This is how they are reacting.